Okay, everybody, this is section 5.1, day 2 of simplifying trig identities. So we need to definitely have your pink trig identity sheet handy because we're going to be doing a little bit more work with that and really trying to hit on all those strategies that we talked about in day 1. So just a quick refresher on strategies. So things like trying to do substitution. So substitute, try to make those expressions the same. And if we can, getting everything into sine and cosine. Sometimes that isn't the most efficient way, but sometimes it's the best way to be able to see what's happening. So we talked about substitution. We talked about order of operations. Just do the problem. A lot of times people get stuck because they just don't know what to do next. Just try doing the problem. Do order of operations. Your PEMDAS. The please excuse my dear Aunt Sally. We talked about factoring, doing factoring in lots of different ways. So that could be GCF. That could be two binomials. It could be difference of squares, whatever that happens to be, but looking for breaking things down into factors sometimes can be helpful, or looking at things that are factored and going the other direction. So we definitely talked about that. And then the last one, rewriting things as algebra. So rewrite as like an algebra sentence. So replacing maybe some of the more complicated ideas like secants, cosecants with just regular variables sometimes can help you see what needs to happen, and that can be a good kind of starter for people. So think about those strategies. Every one of these questions can be done in multiple ways and have different approaches. Some are easier than others, but we always go back to those basic strategies. All right, so let's take a look at this one. This will be our starter one. So we're going to do 5 examples on this day too. We're going to hit some of the things that we talked about or introduced from yesterday, but then also some new ones as well. All right, so this is really similar to one we did yesterday, so please jot it down so you have it. All the functions are different though. We have a sine, a cosine, and a cotangent. So we can't really do order of operations. There's nothing really to factor. There's no GCF to pull out. We could rewrite it as an algebra, but basically that would be 3 different letters that we can't put together. So I think substitution is probably going to be our best bet. Since 2 of them are already in terms of sine and cosine, my attention immediately kind of goes to this cotangent here to see if there's something that I can do to rewrite that. So for cotangent, I think I would rewrite that and look at your pink sheet and see what your options are. So pause if you need to, or pause the video if you need to, so you don't just get that next the next thing right away if you want to look at it yourself. But there's 1 over tangent as an option, but no other tangents. How about the other version, which is cosine of theta over sine? Because the other 2 functions already have sine and cosine in them. So cosine and sine, I don't think I would do anything to replace them, because the only substitutions would be 1 over secant and 1 over cosecant, which I don't know are too helpful. Another hint we talked about yesterday was anything that's not a fraction already, rewrite it as 1. So you can really keep all of those as ratios. People get mixed up, like is it in the top, is it in the bottom? It's easier to tell if you just write everything as a fraction. Okay, so order of operations next. You did your substitution. So we did substitution. Now it's PEMDAS time. It's order of operations, like just do the problem. This is where a lot of people get stuck. They just don't know what to do. Do the operations. I see addition and I see times. We multiply first. So remember, with fractions, you don't need a common denominator to multiply. So it's just top with top. So cosine squared and sine times 1. And then we have our sine over 1. Okay, so now we have to do some addition. We have to have a common denominator to add, though, and that's kind of the new piece that we're adding in today. Get it, adding in. Good one. Really punny. We want to make sure that we can put those together, though. So I need to get a common denominator, and this one has sine, this one has 1, which means I need to multiply that first fraction, top and bottom, by sine, and that would give me sine squared over sine plus cosine squared over sine. So that idea of getting a common denominator, multiplying by that factor that we need, is what we're going to be doing today with those trig identities. So now we can actually put them together. There's a common denominator. But I can't actually combine those 2 terms in the numerator. Sine squared and cosine squared are not like terms. But I'm curious if you can look at your formula sheet and pause again if you need to. Is there anything we can do to make this better? We're going to go back to that. Let's take a look and see if there's a substitution I can make, because those are different functions, right? All right, check the Pythagorean list. And I want you to clue in on this guy up here. And whenever you see a squared, think about the Pythagorean list. What is sine squared plus cosine squared? Well, that, of course, we know is 1, so we get to 1 over sine. And 1 over sine, that's great. We got it down to something that's way easier, right? But that can even go further. 1 over sine is the same as cosecant, which I would say is a more simplified answer. You only have a single function. You don't have an operation anymore. It's a little bit easier to deal with. So if we can get it all the way down to that, that's fantastic. So notice all the different things we did here. We had to look at some substitutions and some order of operations to make sure that we could solve. So getting a common denominator is going to be a big part of our kind of progression moving forward. All right, so let's kind of apply that again. Let's try one more. So this is a checkpoint example. Remember, those you can check in the book too and do to have a little bit of extra practice. So let's take a look at this one. So if you can get it jotted down, pause the video if you need to. So 1 over 1 plus sine of theta, and then plus 1 over 1 minus sine of theta. Now there's really no substitutions we can do here at all other than the signs. You could put in a 1 over cosecant instead, but goodness, it's already a fraction. I don't think that's going to help us. We can't use the Pythagorean identities as well, because like this one minus sine, a lot of people say, oh, is that cosine? Nope, it's not squared, which means you can't make that substitution. So we can't substitute that either. So we're really kind of stuck with just doing order of operations. You could rewrite it as an algebra thing if that helped you to think about what you're going to do. This is really the same question in algebra. So it's 1 over 1 plus y and 1 over 1 minus y. So that strategy might be super helpful to think about. So that means in our common denominator, we would need to have both of those fractions. So I would be multiplying by, or factors, 1 minus y top and bottom in the first one, and I'd be multiplying by 1 plus y in the second one. And that's exactly what we're going to do, but with the sine and cosine version and the trig function instead. So that's kind of our strategy. So I'm going to go ahead and do that with our trig function version. So I'm going to multiply that first fraction by 1 minus sine of theta, top and bottom. So 1 minus sine, 1 minus sine. The second one I'm going to be multiplying by 1 plus sine, top and bottom, to get that common denominator. All right, so in the numerators, these are only 1, so that makes it a lot easier. If this was another number, you would have to distribute it through, or if it was another expression, but it's just 1, so that makes our life a little bit easier on this one. So I end up with 1 minus sine over those two, 1 minus sine, and then 1 plus sine. And then in this one, again, if that was a different number, it would actually do something here, but 1 times it, so that would be 1 plus sine up top, and then those same two factors in the bottom, in whatever order you want to write them. Oh, I keep saying sine first in that one. 1 plus for this one. Okay, so now let's see where we're at. When you have to add fractions together, don't forget to actually add them. This is a part that people forget, which is kind of funny. They wanted to start simplifying again. You haven't actually added yet. I know it seems like we've done an awful lot of work, but you didn't add. You just got a common denominator. Now we add. We put together our like terms. So 1 plus 1 would give you 2. Woohoo, can do that. We have a negative sign plus a sign. That's going to add to 0. So actually the numerator just ends up being 0. On the bottom you have some options. Some people might just leave it, but I'm actually going to multiply this out because I think something good's going to happen. So I would encourage you to try multiplying the factors together. So that would be 1 plus sine minus sine, which would add to 0, and then minus sine squared. So your common denominator, both of them, are going to be that same thing. That's 1 minus sine squared. So I'm curious to see if anybody recognizes what's going on here. Is there anything else we can do? So take a peek at that denominator. Do you see this anywhere? Look at your pink sheet. That's actually cosine squared, right? 1 minus sine squared. And this is kind of cool. We can actually go further. We're dividing there, right? We still have a division. Think of it like this. It's sort of like 2 times 1 over cosine squared, if this helps you visualize a little bit. The 1 over cosine squared is the part I want you to think about. So 1 over cosine is equal to secant of theta. So 1 over cosine squared of theta is actually secant squared. If you have a ratio that's just raised to a power, it's that same other side raised to that same power. So this actually ends up to be 2 times secant squared of theta. That's the best, most simplified answer, because notice we don't have division. Most people prefer to have it as a multiplication. So we try to get it down to the easiest expression that we can. Gosh, lots going on in this again, right? We have that whole idea of getting a common denominator and then being able to simplify that. All right, so we're going to finish up today with a few last examples using trig identities and just pulling together some of the things that we know, but also taking it a little bit further. So let's go ahead to this next one. So we talked about common denominator. Let's send this one a little bit different, more the factoring idea. So look at what it's asking you to do. They want you to rewrite that fraction so that's not a fraction anymore. In other words, see if you can reduce this so it's no longer a fraction. Well, why might they ask you to do that? Well, sometimes it's way easier, right? To not have to deal with a fraction, to be able to have something that's just an easy expression to be able to work with. All right, so there's two different approaches to this one. So I'm going to start with something that hopefully is familiar to you. I'm going to bring you back to when we worked with complex numbers and we talked about conjugates. Okay, so in a lot of these Pythagorean identities, we're multiplying a factor times its conjugate. So if you remember what conjugates are, if you have a plus bi, we did this for like imaginary, so I'll show it for that. Then the conjugate, see if you remember this term, the conjugate is a minus bi. And if you multiply those two together and do your FOIL, the insides and outsides cancel, remember all that good stuff? Well, we're going to do a very similar idea here. This is one option anyway. I'm going to multiply top and bottom by the conjugate. And the reason is I want to be able to try to see if I can do one of those Pythagorean substitutions. So I need to have some squared stuff with the sign as well. So I'm going to multiply top and bottom by the conjugate. Now that doesn't look like it's going to help you at all because the top's kind of a mess. I'm just going to leave it as multiplication. I'm not actually going to distribute it out yet. But on the bottom, let's go ahead and do FOIL. What you end up getting was 1 minus sine squared, right? So that's doing that multiplication. Now, look on your pink sheet. What's 1 minus sine squared? Well, that's cosine squared. So you have cosine squared in the top times 1 plus sine of theta, and then we can make that substitution. Well, cool. If we make that substitution, watch what happens. I can reduce that fraction. These are multiplied, right? They're factored. So I can divide out my common factors, and you're left with 1 plus sine of theta. In other words, you no longer have a fraction, right? It's the same as simplifying. When they say, hey, don't write it as a fraction anymore, they mean simplify this. This is way too yucky to look at. So that's one option. You can multiply by a conjugate. Works really well. But if you don't recognize that, and that's hard for you to see, here's another option. I know it seems a little bit like you're going in the wrong direction, but what if I just went ahead and just replaced that, substituted that immediately? Look at your Pythagorean list. Cosine squared is equal to 1 minus sine squared. Now, a lot of people get to this and they want to start just canceling out signs here. Oh, look, I can cross out this one with this. No, you can't. Can't do that, can't do that, can't do that, because that is a fraction that has adding and subtracting in it. So it's not factored. You can't just take out the sign. You can't just take out parts. But what you can do is you can take this difference of squares. Remember, this is like, let's rewrite it as an algebra thing. That's like 1 minus y squared, which we know we can factor. 1 plus y, 1 minus y. Let's think of it that way. That means it would be 1 minus sine of theta times 1 plus sine of theta. And watch what happens. That common binomial factor divides out, and we're left with the exact same thing we had before. Multiple avenues, right? Different ways. Now, me personally, I like the second way. I think that's a little bit faster way to deal with it. So again, lots of different avenues and things to look for. We just need the experience to be able to see our options. All right, so we're going to finish up with a couple different things, some different substitution things that we can do to try to rewrite things as trigonometric functions. So kind of fits into this and helps us get ready for some calculus ideas. So I'm going to give you some information about a trig function. So x equals 3 times the sine of theta. They're telling you that theta is between 0 and 2 pi, or pi over 2. So think about that, 0 and pi over 2. That means we're talking about quadrant 1. In other words, everything will be positive. They want you to write this as a trigonometric function of theta. What? Sounds terrible. They want you to rewrite some horrible looking expression as a trigonometric function in terms of theta. All right, well, basically all they're asking you to do is use a substitution. Instead of saying x, they want you just to write it as a trig function. We're going to draw the picture too so you can see why that might happen, but let's take a look and see what that is. So I'm just going to replace x with what it's equal to. So 9 minus, going to do that substitution, so 3 times the sine of theta, and then we have to square that. So we can make the substitution because they told us a value. So in calculus next year, you're going to be doing substitutions like this all the time. I'm replacing a function into another function, and we can do that with trig as well. So let's simplify this a little bit. So we have 9 minus, I need to square 3 sine of theta. So 3 squared would be 9, and then sine times sine would be sine squared. All right, which seems like, that's a function of theta, right? Like we kind of accomplished the quest there, but I bet we can simplify this even more. So let's think about that factoring idea. Do you notice your GCF in there? So that would be 9 times 1 minus sine squared. And then, what's 1 minus sine squared? So we remember we have these different options. That's cosine squared. So we have 9 times cosine squared. Now it's a perfect square. Square root of 9 is 3. Square root of cosine squared is cosine, which is why it was important they told us that it's in quadrant 1, so we don't need to worry about plus or minus, right? It's only going to be positive because those values are only going to be positive there. So it's kind of cool to take a peek at that and see. Now, that's just doing the substitution and doing the arithmetic. I'm going to go back up and talk about the picture. Let's see if we can draw that. So I'm going to rewrite this and solve it for sine of theta. So they told me that x was 3 times the sine of theta. Let's go ahead and divide both sides by 3. So that means sine of theta is equal to x over 3. That's the ratio that they're giving you. So let's see if we can replicate that. We know it's in quadrant 1. So let's draw our triangle here. So sine, remember, is opposite over hypotenuse. So this would be x, this would be 3. Let's see if we can figure out what information that they were trying to tell us here. We can actually figure out this other side of the triangle. We can see where they're getting this relationship from. If you find this third side of the triangle, so we do 9 squared equals x squared, which is the height plus, and I'll just call it b squared for right now. Let's go ahead and solve. So I would subtract the x squared. So we'd have 9 squared. Oh, sorry, not 9 squared, just 9. That's 3 squared. Duh. All right, so 3 squared. I'll just write it that way now. So 9 minus x squared equals b squared. And then to undo squaring, I'm going to square root. And so that would give me that other side of the triangle. That would be 9 minus x squared. Now here's the cool thing. 9 minus x squared, right? That's the expression for the other side. That was actually the expression they were having you substitute it into. Look what we said it was equal to. 3 cosine of theta. Well, look at your angle measurement here. What would the ratio for cosine be in this triangle? Cosine of theta. It would be that over 3. Right? So it's that same exact expression. So the square root of 9 minus x squared over 3. So if you just solve for the 9 minus x squared, that is your 3 cosine theta that you said it would be. Kind of cool, that relationship as we go back and forth. So that's something that we're going to be talking about in calculus again, kind of translating that SOHCAHTOA kind of ratio, the triangle, and then being able to look at it in terms of x's and y's, but also being able to look at it in terms of sines and cosines. So we can kind of translate back and forth. It's pretty cool to be able to do that. So just being able to substitute, that's something that we'll be continuing to talk about. So kind of a cool thing. For you, though, just being able to plug it in and simplify is what we're looking for right now. All right, now we can also do this with logs. Love this. So we're going to rewrite and do this logs with sine and cosine. So super cool. Being able to put things together using log properties. So got to really go back in your thinking here. They want you to write it as a single log. We did a bunch of this earlier, but not really with sines and cosines. So now we're just adding in the fact that we can do anything with trig that we can do with regular algebra, and it's awesome. Okay, so see if you remember the log property. The sum of two logs is the same as the log of the what? What do we do with those two expressions on the inside? Well, adding goes with multiplication. And if this was subtracting, it would be divide. So just so you know the difference between those. So how is this going to help me write it as a single log? Well, instead of having it be added, now we have it log of the product. We put it together. But I bet we can do some simplifying in here. Secant and sine are not the same function, so I can't actually multiply them. But secant, remember, is 1 over cosine. That's really the only thing I can do there. But now at least I can multiply those two fractions together, right? So the natural log of, remember multiplication, don't need a common denominator, so it'd be sine over cosine. All right, but what is sine over cosine? Now that's not so bad, but I think that's equal to something, isn't it? Check your pink sheet. Sine over cosine is tangent. So it's actually equal to the natural log of tangent. Being able to simplify with logs and exponentials too, actually, but logs with trig functions is going to be a part of our journey when we get to calculus as well. So just being able to recognize and put together. All right, so this day 2 really hits kind of two other ideas. Being able to do adding and subtracting with all of those other strategies that we talked about, and then also being able to recognize that you can use trig functions in other applications like substitution and these log ones like the last couple. So we get some really cool things to look at. So our day 2 is going to hit some of those. You're going to have some more simplify ones. You're going to have some adding and subtracting where you're going to have to do some common denominator. And then you're going to have, I'm just going to scooch down here so you can see, oops. You're going to have a couple substitutions. So you see 3 of those. And then you have some log properties, kind of cool. This number 66 is another calc application. So you see a lot of those symbols next to like 58 and 66. We're getting into a lot of the calculus applications now. So there's your day 2 assignment. And then we're just going to be doing a couple days of practice then to really make sure that all these strategies make sense. Day 2.